The hidden ocean beneath Antarctica. For most of human history, Antarctica was little more than a blank space on maps. It was a world of ice, wind, and isolation. A continent larger than Europe, hidden beneath a frozen shell that in some places reaches more than 4 kilometers in thickness. For centuries, explorers dreamed of reaching its interior. Many never returned. Those who survived described a landscape unlike anywhere else on Earth. Temperatures low enough to freeze exposed skin in moments. Winds capable of overturning vehicles. A silence so complete that people sometimes reported hearing their own heartbeat echoing inside their heads. Yet even the earliest explorers could not imagine what was hidden beneath the ice. Far below the frozen surface of Antarctica lies one of the most extraordinary places ever discovered on our planet. A vast lake, an ancient body of water, a lake that has been sealed away from the atmosphere for hundreds of thousands and possibly millions of years. A lake known as Lake Vostok. The story of its discovery begins not with water, but with a scientific mystery. During the middle of the 20th century, researchers studying Antarctica noticed something unusual. Radar signals sent into the ice sometimes behaved strangely. Instead of reflecting from solid rock below, certain signals appear to bounce off an unexpectedly smooth surface. At first, scientists assumed the equipment was malfunctioning. The Antarctic environment was brutal on electronics. Strange readings were common. But as technology improved, the anomaly continued to appear. Again and again, instruments suggested the presence of something flat and reflective beneath the ice sheet. The evidence remained uncertain for years. Then satellite observations began providing a clearer picture. Scientists noticed that a section of the ice surface above the anomaly was remarkably smooth compared to surrounding regions. This was an important clue. Ice flowing over rugged mountains tends to become uneven. Ice floating over liquid water remains far smoother. The implications were astonishing. Could there really be liquid water trapped beneath kilometers of Antarctic ice? At first glance, the idea seemed impossible. Antarctica is the coldest continent on Earth. Temperatures can fall below -80 degrees Celsius. How could a lake remain liquid under such conditions? The answer lies in pressure and heat. The immense weight of the ice sheet creates enormous pressure deep below the surface. At the same time, heat slowly rises from Earth's interior. Together, these factors can prevent water from freezing completely. By the 1990s, scientists had gathered enough evidence to reach a remarkable conclusion. A giant lake existed beneath the ice. Not a small pond, not a hidden stream. A lake approximately 250 kilometers long and 50 kilometers wide, one of the largest freshwater lakes on Earth, and it had remained hidden for countless generations. The discovery transformed scientific understanding of Antarctica. Researchers soon identified dozens of smaller subglacial lakes scattered beneath the continent. Eventually, hundreds would be discovered. Yet Lake Vostok remained unique. It was by far the largest and most mysterious. Named after the nearby Russian research station, the lake immediately captured global attention. Scientists recognized that it represented something far more valuable than a geological curiosity. It was a natural time capsule, a completely isolated environment, a place where life, if present, might have evolved separately from the rest of Earth's ecosystems for extraordinary periods of time. The possibility raised profound questions. What if microorganisms had survived in complete darkness for hundreds of thousands of years? What if entirely unknown forms of microbial life existed there? What adaptations would be necessary to survive under immense pressure and permanent isolation? The answers could reshape biology. They could also help scientists understand where life might exist elsewhere in the solar system. Because Lake Vostok has an important connection to another world, far from Earth, beneath the icy crust of Jupiter's moon, Europa, scientists believe a global ocean may exist. Similar possibilities have been proposed for Saturn's moon Enceladus. Both worlds are covered in ice. Both may contain liquid water below. Both are among the most promising locations in the search for extraterrestrial life. In many ways, Lake Vostok serves as a natural laboratory for studying these distant environments. If life can survive in the darkness, beneath Antarctica, perhaps life can survive beneath the ice of other worlds as well. As excitement grew, scientists faced a difficult challenge. How could they explore the lake without contaminating it? This question became one of the most debated topics in polar science. For decades, researchers had been drilling deep ice cores near Vostok Station. These cores provided valuable information about Earth's climate history. Each layer of ice preserved tiny samples of ancient atmospheres. Air bubbles trapped thousands of years ago remained frozen within the ice. By studying them, scientists reconstructed past climates with remarkable accuracy. The drilling operation gradually descended deeper and deeper. Eventually, researchers approached the lake itself. This created a dilemma. Reaching the water would be a historic achievement, but introducing modern bacteria into an untouched ecosystem could permanently alter it. Many scientists argued for extreme caution. Others believed exploration was essential. Years of debate followed. International committees examined possible risks. Engineers developed new procedures. Environmental concerns remained at the center of every discussion. The deeper scientists looked into Lake Vostok, the more mysterious it became. The lake sits beneath nearly 4 kilometers of ice. The pressure at its surface is immense. Sunlight has never reached its waters. No fish have been observed. No plants have been seen. No direct human exploration has ever taken place. Yet despite these extreme conditions, evidence continued to suggest that the lake might not be sterile. Some studies detected traces of biological material in ice formed from frozen lake water. Other analyses hinted at microbial activity. The findings were controversial. Some researchers believed contamination explained the results. Others argued the evidence pointed toward a genuine ecosystem. The debate continues even today. One of the most fascinating aspects of Lake Vostok is its age. Scientists estimate that parts of the lake may have been isolated from the atmosphere for hundreds of thousands of years. Some estimates extend into the millions. To appreciate this timescale, consider that human civilization is only a tiny fraction of that age. Entire species have appeared and disappeared during the period that Lake Vostok remained hidden beneath the Antarctic ice. The lake has quietly existed through ice ages, volcanic eruptions, and the rise and fall of civilization. While empires expanded and collapsed, its dark waters remained untouched. And somewhere beneath nearly 4 kilometers of ice, one of Earth's greatest scientific mysteries still waits to be fully explored. For scientists, Lake Vostok represented something extraordinarily rare. Most environments on Earth are connected to one another. Oceans exchange water, rivers carry nutrients, winds transport microorganisms across continents. Even the deepest parts of the sea are influenced by processes occurring at the surface. Lake Vostok is different. It exists beneath a barrier of ice so thick that it effectively separates the lake from the outside world. This isolation makes it one of the most unusual environments ever discovered. Researchers began asking a simple but profound question. What happens to a body of water when it remains sealed away for such a long period of time? The answer was far from obvious. Some scientists believed the lake might be nearly lifeless. The reasoning seemed straightforward. No sunlight reaches the water. Without sunlight, photosynthesis cannot occur. Without photosynthesis, complex food chains become difficult to sustain. The lake appeared to be an environment where survival would be almost impossible. Yet nature has repeatedly surprised scientists. Life has been discovered in places once thought completely uninhabitable. Microorganisms thrive near hydrothermal vents at the bottom of the ocean. Others survive inside rocks deep underground. Some endure temperatures that would kill most known organisms. Others live in highly acidic lakes or beneath glaciers. Each discovery expanded the known limits of life. Lake Vostok became the next great test. If organisms existed there, they would need entirely different strategies for survival. Instead of sunlight, they might rely on chemical reactions. Instead of surface nutrient, they might obtain energy from minerals released by the lake bed. Such ecosystems already exist in isolated parts of Earth. Could Lake Vostok contain something similar? The possibility fascinated scientists around the world. During the late 20th century, Advances in radar technology revealed more details about the hidden lake. Measurements suggested that Lake Vostok was not merely a shallow pool trapped beneath the ice. In places, the water appeared hundreds of meters deep. Some estimates suggested depth approaching 1,000 meters. This made the lake not only large in area, but also immense in volume. The amount of water trapped beneath Antarctica was staggering. Researchers also discovered evidence that the lake might not be completely still. Water circulation appeared possible. Temperature differences within the lake could drive slow currents. If true, nutrients and microorganisms might move throughout the hidden ecosystem. The image emerging from the data was increasingly complex. Lake Vostok was beginning to resemble an entire world concealed beneath the ice. The challenge was proving it. At Russia's Vostok station, conditions were among the harshest on Earth. The station itself sits in one of the coldest locations ever inhabited by humans. In 1983, temperatures near the station dropped below -89 degrees Celsius. It remains one of the coldest naturally recorded temperatures on Earth. Working there requires constant preparation. Machinery can fail without warning. Fuel can thicken in extreme cold. Metal becomes brittle. Even simple tasks become difficult. Yet despite these challenges, scientists continued drilling. Year after year, the drill descended deeper into the Antarctic ice sheet. The ice cores recovered during this effort became invaluable. Each section preserved a record of ancient climates. Tiny bubbles trapped inside the ice contained samples of Earth's atmosphere from long ago. Scientists could analyze carbon dioxide level, methane concentration, and other atmospheric components. The cores revealed details about past ice ages and warming periods. They became one of the most important climate archives ever collected. But as the drill approached Lake Vostok, attention shifted. The ancient climate record was no longer the only prize. Beyond the final layers of ice waited water that no human had ever seen. The closer researchers came to the lake, the more intense the debate became. Environmental organizations expressed concern. Scientists worried about contamination. Some argued that drilling technology was not yet clean enough. Others warned that introducing modern microbes could permanently alter a pristine ecosystem. The concern was not theoretical. Human activity has repeatedly affected remote environments. Species have been transported across ocean. Bacteria have contaminated isolated regions. Even careful scientific missions carry risks. Protecting Lake Vostok became a global responsibility. As discussions continued, engineers developed increasingly sophisticated methods. The goal was clear: reach the lake while minimizing contamination. Achieving that goal would require patience and precision. The world watched closely. Then came one of the most significant moments in Antarctic exploration. After decades of effort, Russian researchers announced that they had finally reached Lake Vostok. The achievement marked a historic milestone. For the first time, humanity had accessed one of Earth's most isolated environments. The announcement generated worldwide excitement. News organizations reported the breakthrough. Scientists celebrated the accomplishment, yet many questions remained unanswered. Reaching the lake was only the beginning. Understanding it would take years. Samples collected near the lake immediately became the focus of intense study. Researchers searched for evidence of life. They analyzed chemical signatures. They examined traces of biological material. The results were intriguing. Some studies reported signs consistent with microbial activity. Others questioned whether contamination might explain the findings. Scientific debate intensified. This uncertainty is common in frontier research. Extraordinary discoveries require extraordinary evidence. Researchers carefully examined every possibility. Were the detected organisms truly from Lake Vostok? Had they survived in isolation for immense periods of time, or were they introduced during drilling operations? Definitive answers proved difficult to obtain. Despite the uncertainty, one fact remained clear. Lake Vostok had become one of the most important natural laboratories on Earth. The lake was teaching scientists something fundamental. Life may be far more adaptable than previously imagined. This realization extended far beyond Antarctica. It influenced planetary science, astrobiology, and the search for life beyond Earth. If microorganisms could survive beneath kilometers of Antarctic ice, then similar environments elsewhere suddenly appeared more promising. Scientists began drawing comparisons to Europa. Europa, one of Jupiter's largest moons, possesses an icy crust covering a vast ocean. Unlike Earth, Europa receives very little solar energy. Yet evidence suggests liquid water exists beneath its frozen surface. The parallels were impossible to ignore. Both environments involve water hidden beneath thick ice. Both are isolated from direct sunlight. Both could potentially support microbial ecosystems. Lake Vostok offered a glimpse into conditions that might exist hundreds of millions of kilometers away. The same comparison applied to Enceladus. This small moon of Saturn astonished scientists when spacecraft observed enormous plumes erupting from its south polar region. The plumes contained water vapor and organic compounds. These discoveries transformed Enceladus into one of the most intriguing places in the solar system. Again, Lake Vostok served as an earthly analog. Studying Antarctica could help scientists prepare for future missions to distant worlds. In this way, a hidden lake beneath Earth's ice became connected to one of humanity's greatest questions. Are we alone in the universe? The answer may depend partly on understanding environments like Lake Vostok. Every new sample, every new measurement, every new analysis contributes another piece to the puzzle. Yet despite decades of research, much remains unknown. The lake still hides countless secrets beneath the Antarctic ice. Its waters remain largely unexplored. Its ecosystem, if one exists, remains mysterious. Its history continues to challenge scientific understanding. And somewhere in the darkness, beneath 4 kilometers of ice, a hidden world continues to wait in silence, just as it has for countless generations. For many people, the most astonishing aspect of Lake Vostok is not its size, it is its silence. Imagine a world completely cut off from sunlight. No sunrise, no sunset, no moonlight reflected across the water, no storms visible overhead, no seasons in the familiar sense, only darkness. A darkness that may have remained uninterrupted for hundreds of thousands of years, perhaps longer. Human beings struggle to comprehend such timescale. Entire civilizations rise and fall within a few thousand years. Languages appear and disappear. Empires expand and collapse. Yet throughout these changes, Lake Vostok remained hidden beneath Antarctica, isolated from almost everything happening on the surface of Earth. This isolation creates one of the greatest scientific opportunities of modern times. The lake is not merely a body of water. It is a natural archive, a record of geological and biological processes preserved in extraordinary conditions. Scientists believe sediments on the lake floor may contain clues stretching far into Earth's past. These sediments accumulate slowly, layer after layer, year after year, century after century. Like pages in a book, they preserve information about ancient environments. If researchers eventually obtain uncontaminated sediment samples, they may discover evidence of climatic changes that occurred long before human civilization existed. The information could improve understanding of Antarctica's history. It could reveal how ice sheets expanded and retreated. It could help scientists understand how Earth's climate system responded to natural changes in the distant past. Such knowledge has become increasingly valuable. Modern climate research depends heavily on understanding historical patterns. The better scientists understand the past, the better they can interpret the present. Lake Vostok may hold some of the oldest and most complete records available anywhere on Earth. Yet the possibility of ancient climate information is only part of the story. The lake also raises fascinating geological questions. Antarctica is often imagined as a continent of ice alone. In reality, beneath that ice lies a complex landscape: mountains, valleys, ancient river systems, buried geological structures. The continent underneath the ice is far more dynamic than many people realize. Lake Vostok occupies a depression within this hidden landscape. Scientists suspect that geological processes helped shape the basin long before it became covered by ice. Understanding those processes may reveal important details about Antarctica's distant history. Researchers have used satellite, radar systems, seismic measurements, and computer models to reconstruct the lake's structure. The emerging picture is remarkable. The lake appears divided into different regions. Some sections may be relatively shallow, others are considerably deeper. The shape of the lake floor remains uncertain. Without direct exploration, many details remain speculative. Each new study adds information, but also introduces new questions. This pattern is common in science. Every answer often reveals additional mysteries. One of the most intriguing discoveries involves the ice directly above the lake. Scientists found evidence that water from the lake freezes onto the bottom of the overlying ice sheet. This process creates what researchers call accretion ice. Unlike ordinary glacier ice formed from snowfall, accretion ice originates from the lake itself. In effect, tiny samples of the hidden environment become incorporated into the ice above. These frozen layers provide a rare opportunity. Researchers can analyze material originating from the lake without directly entering the water. The findings have generated significant interest. Within some accretion ice sample, scientists identified chemical signatures potentially associated with biological processes. The interpretation remains debated. Some researchers argue the evidence suggests microbial life. Others emphasize the need for caution. Contamination remains a concern whenever samples are collected from extreme environments. Scientific progress often moves slowly for this reason. Extraordinary claims must withstand intense scrutiny. Yet regardless of interpretation, the results demonstrate that Lake Vostok remains scientifically compelling. The possibility of discovering unique microorganisms continues to motivate research efforts. If such organisms exist, they may possess unusual adaptations. The environment beneath the ice is unlike most habitats on Earth. Pressure is immense. Nutrient availability is limited. Temperatures remain near freezing. Light is completely absent. Any life surviving there would require specialized biological strategies. Researchers are particularly interested in how microorganisms obtain energy in such conditions. On the surface, many ecosystems depend ultimately on sunlight. Plants capture solar energy through photosynthesis. Animals consume plants or other animals. Energy flows through complex food webs. In Lake Vostok, that pathway is unavailable. Instead, life would need alternative sources of energy. Scientists have proposed several possibilities. Chemical reactions involving minerals could provide energy. Interactions between water and rock may release compounds usable by microorganisms. Geothermal activity beneath the lake could contribute as well. Similar processes support life in other extreme environments. Hydrothermal vent ecosystems in the deep ocean offer one example. There, microorganisms thrive without sunlight by exploiting chemical energy released from Earth's interior. The existence of such ecosystems transformed scientific understanding of life's limits. Lake Vostok may reveal whether comparable strategies operate beneath Antarctic ice. The implications extend far beyond biology. They influence one of humanity's most profound scientific pursuits, the search for extraterrestrial life. For centuries, discussions about life beyond Earth remained largely philosophical. Modern science has changed that. Spacecraft observations have revealed environments throughout the solar system where liquid water may exist. Mars shows evidence of ancient rivers and lakes. Europa appears to contain a global ocean beneath ice. Enceladus ejects water-rich plumes into space. Titan possesses complex organic chemistry. Each discovery expands the range of potentially habitable environments. Lake Vostok provides a valuable natural analog. By studying life in isolated Antarctic waters, scientists gain insight into what might be possible elsewhere. Future missions to icy moons may encounter conditions surprisingly similar to those beneath Antarctica. Engineers already examine Antarctic exploration techniques when designing planetary missions, drilling through thick ice, preventing contamination, collecting pristine samples. These challenges exist both on Earth and beyond. In a sense, Antarctica has become a training ground for future exploration of alien oceans. The hidden lake beneath the ice has therefore assumed a significance that reaches far beyond its geographic location. It is simultaneously a geological mystery, a biological laboratory, a climate archive, and an analog for other worlds. Few places on Earth combine so many scientific disciplines in a single location. And despite decades of study, the most important discoveries may still lie ahead. The vast majority of Lake Vostok remains unexplored. No submarine has mapped its depths. No human has observed its waters directly. No camera has recorded images from its hidden interior. The lake remains largely as mysterious today as it was when scientists first suspected its existence. That fact alone is remarkable. In an age of satellites, global communication networks, and advanced technology, one of Earth's largest lakes remains hidden beneath 4 kilometers of Antarctic ice. Its waters continue to wait in darkness. Its secrets remain locked beneath the frozen continent. And every year, scientists return to Antarctica, hoping to learn a little more about the hidden world that has existed beneath the ice for far longer than human history itself. As scientific interest in Lake Vostok continued to grow, researchers began to realize that the lake was only part of a much larger story. Antarctica itself was changing, not rapidly in the way that weather changes from day to day, but on geological timescales. The continent had not always been the frozen wilderness we know today. Millions of years ago, Antarctica looked dramatically different. Ancient forests once grew across large portions of the continent. Rivers flowed through valleys. Dinosaurs walked across landscapes that now lie buried beneath kilometers of ice. Evidence of this distant past has been discovered in fossil rock formations and sediment deposits. The realization surprised many people. It is difficult to imagine trees growing in a place where winter temperatures can fall below -80 degrees Celsius. Yet Earth has experienced many different climates throughout its history. Antarctica's transformation into a frozen continent occurred gradually as global temperatures changed and continental positions shifted. Ice sheets expanded. Over immense periods of time, the ice became thicker and more extensive. Eventually, much of the continent disappeared beneath a vast frozen blanket. Lake Vostok may contain clues from these ancient transitions. Sediments on the lake floor could preserve information from periods before the modern Antarctic ice sheet fully developed. If researchers can access those sediments safely, they may gain insight into some of the most dramatic environmental changes in Earth's history. The challenge remains enormous. Drilling through nearly 4 kilometers of ice is difficult enough. Recovering uncontaminated samples from beneath the ice is even more demanding. Scientists must balance exploration with preservation. Every action carries consequences. This careful approach reflects lessons learned from previous scientific expeditions. History contains many examples of discoveries that were damaged by inadequate protection. Researchers are determined not to repeat those mistakes. As technology advances, new methods are being developed. Robotic probes designed for sterile operation have become increasingly sophisticated. Autonomous systems may eventually allow scientists to explore the lake with minimal environmental impact. Some proposed designs resemble miniature submarines. Others function more like intelligent sensors. Each concept aims to answer the same question: what truly exists beneath the ice? The answer remains uncertain. Some scientists envision a relatively simple microbial ecosystem. Others believe more complex biological communities could be possible. Most researchers agree that expectations should remain cautious. Extreme environments often support life, but not always abundant life. Nevertheless, even the discovery of a single previously unknown microorganism would be scientifically significant. Such organisms could reveal new biochemical pathways. They might possess enzymes adapted to extraordinary conditions. Their genetic structures could improve understanding of evolution in isolated environments. Already, microorganisms discovered in other extreme habitats have produced important scientific insights. Some have contributed to advances in biotechnology. Others have expanded understanding of life's resilience. Lake Vostok could offer similar surprises. One reason the lake attracts so much attention is that it challenges assumption. For much of scientific history, environments lacking sunlight were considered poor candidates for supporting life. Modern discoveries have repeatedly overturned that assumption. Life has proven remarkably adaptable. Researchers have found organisms surviving beneath glaciers, inside volcanic rocks, in highly acidic lakes, and near hydrothermal vents deep beneath the ocean. Each discovery forced scientists to reconsider where life can exist. Lake Vostok represents another step in that ongoing process. Its isolation makes it especially valuable. Unlike many other environments, it has remained separated from direct atmospheric influence for extraordinary periods of time. This isolation creates conditions rarely found elsewhere on Earth. Studying such conditions can reveal processes that would otherwise remain hidden. The lake has also inspired public imagination. Stories about hidden worlds beneath Antarctica have circulated for decades. Many are fictional. Some involve lost civilization. Others describe secret chambers or mysterious creatures. These stories often bear little resemblance to scientific evidence, yet they reflect something important. Human beings are naturally fascinated by the unknown. Lake Vostok embodies that fascination. It is a real mystery, not because of speculation or fantasy, but because genuine scientific questions remain unanswered. The unknown is often more interesting than fiction. A hidden lake larger than many countries, buried beneath kilometers of ice, potentially isolated for hundreds of thousands of years, possibly containing forms of life adapted to conditions unlike those experienced by most organisms on Earth. Such facts require no embellishment. They are remarkable on their own. Meanwhile, advances in satellite technology continue providing new information. Modern instruments can detect subtle changes in ice elevation. They can measure movement across vast distances. They can reveal structures hidden beneath the surface. These observations help scientists understand how Lake Vostok interacts with the surrounding ice sheet. The relationship is complex. Ice slowly flows across Antarctica. The lake influences that flow. Water, pressure, temperature, and geology interact in ways researchers are still attempting to fully understand. Computer models have become increasingly important. By combining observations with simulation, scientists can test different hypotheses. They can estimate circulation patterns within the lake. They can examine how heat moves through the system. They can explore scenarios that would be impossible to observe directly. Each improvement in modeling brings researchers closer to understanding the hidden environment. Yet uncertainty remains. And uncertainty is not a weakness in science. It is often where the most important discoveries begin. Every major scientific breakthrough started with unanswered questions. Lake Vostok continues to generate many of them. How old is the lake's current ecosystem? If one exists, what organisms inhabit its waters? How does energy circulate through such an isolated environment? What secrets lie within the sediments at the bottom? How similar is the lake to icy oceans elsewhere in the solar system? Can exploration occur without contamination? These questions drive ongoing research. They motivate new expeditions. They inspire new technologies. And they remind scientists that even on our own planet, important mysteries remain unsolved. In an era when maps cover every continent and satellites circle the globe, it is easy to assume that Earth has revealed all of its major secrets. Lake Vostok demonstrates otherwise. Beneath Antarctica's frozen surface lies a world that remains largely unexplored, a world hidden in darkness, a world protected by ice, a world that has persisted through countless generations of human history without being seen. And somewhere beneath that immense frozen barrier, the waters of Lake Vostok continue their silent existence, waiting for future explorers to uncover the next chapter of one of Earth's most extraordinary scientific mysteries.